All right, calculus, welcome to some remote calculus evaluating limits intro notes. Again, this is for remote calculus, but anyone in calc can watch this for some extra help. I'm going to skip over the graphical. Looking at this graphically, we can see, as x is approaching a certain number, what is y approaching? Okay, we took a look at that. If we had jump discontinuities, if we had a whole vertical asymptotes involved at the left side matched the right side, we were able to tell different limits looking at them graphically. Now we're going to spend a lot of time looking at them algebraically. So the limit as x goes to 3, these are some easier ones. X squared minus 9 over x squared minus x minus 6. What we would do here is, first off, if you plug 3 in, you get the indeterminate 0 over 0 case. That's no good. Doesn't tell you anything. So we got the limit as x goes to 3. Yes, you have to write that. Of factor the top, x squared plus 3, x squared minus 3. Factor the bottom, x minus 3, x plus 2. Okay, then we take a look here, and we notice that the x minus 3's will cancel, which is great. It was causing the issue here in the denominator. So now we have the limit as x goes to 3 of x plus 3 over x plus 2. Now when I plug 3 in, I do not get 0 over 0. In fact, I can now plug 3 in. I do not have to write the limit as x goes to 3. I will let x go to 3, and I get 6 over 5. 6 over 5. All right, I got rid of that removable discontinuity. It's approaching y value of 6 over 5 from the left and the right. All right, so that's the name of the game, especially on this first homework set that everyone has. So take a look here at number 2. The limit as x goes to 4 of x squared minus 16 over 4 minus x. Again, if you plug it in, do a quick check, because some of these you might be able to do, but just by plugging it in. If you plug this in, you get 0 over 0. The denominator is 0. That means we definitely need to try to factor. So we're left with x plus 4, x minus 4, over 4 minus x. Now, these two, x minus 4 and 4 minus x, they cancel. They're negative 1. All right? Just let x be 0. You got negative 4 over positive 4. Let x be 5. You got 1 over negative 1. These cancel to give you negative 1. So now I have the limits as x goes to 4 of the opposite, or negative 1, times x plus 4. Nothing in the denominator. So now I can plug 4 in for x. My answer will be negative 8. Negative 8. All right, rolling on through here. I have 3 of these that I want to do. All right, so let's keep going. Limit as x goes to negative 2 of 5x plus 10 over x squared minus 4. Again, you get the 0 over 0 case. Factor time, the limits. So x goes to negative 2 of 5x plus 2 over x minus 2x plus 2. All right, cancel time. X plus 2 over x plus 2. The limit as x goes to negative 2 of 5 over x minus 2. Plug negative 2 in for x. Now, because, again, I will not have dividing by 0 case. Plug negative 2 in for x. Plug negative 2 in for x. I get negative 4 in the denominator, so I get a negative 5/4. Again, I do want you to show me more arithmetic here in your homework than is necessary for a quiz or a test in my presence. All right, take a look at 4. 5 is delightful. Number 4, here's the limit as x goes to 0 of x to the third minus 9x squared plus 7x over 4x. So up top, what we're going to do, limits as x goes to 0 of x times x squared minus 9x plus 7 divided by 4x. All right, the x's will cancel. Again, this won't factor, and I don't really need to worry about trying to make it factor, because now I got that x out of the denominator x squared minus 9x plus 7 divided by 4. I can let x be 0, and I'm left with 7/4. All right, then take a look at something like 5. You have several of these in your first homework sets. We don't expect a ton of them overall. But I can simply let x be -3. It's nothing to factor. All right, so I can simply let x be 3. I get the square root of 27, which is 3√3. All right, that one's great. Just kind of do it. Then, as we progress, I think we have another one like that. Sometimes students get confused. They're like, I normally factor on these. I could just let x be 7, okay? And this, you know, upside down parabola there. You know, as x goes to 7, again, this is just made up, you know. There, it's continuous, all right? We just simply say what the y value is going to be. So 8 times 7 minus 2 times 7 squared plus 11. 56 minus 49 doubled plus 11 is, was that -31? All right, so then on 7, taking us back to Algebra 2 at Chapter 6. The limits as x goes to -3 of, this is a sum of perfect cubes. So it's x plus 3 times that first term squared. Minus, because again, x squared and x's aren't present. You got to have something cancel. So we need the negative to cancel the x squareds and the x's. And it's the inner product, 3x plus the second term squared. We have to have that down. The x plus 3's would cancel, leaving you with the limit as x goes to -3 of x squared minus 3x plus 9. And then plug -3 in. $27. Let's talk about number 8 here as we get close. So this one's interesting here. When you have the root involved, again, plug 0 in, you get, or plug 0 in, you get 0/0, the indeterminate case. So, you know, in Algebra 2, we probably would have kept this as an answer, but if we're letting x go to 0, that's no bueno. The only way to get rid of this root here and this other term, we've got to multiply the top and bottom by the conjugate. So x plus 4, that same term, plus 2. Same two terms, but opposite signs in between. All right, multiply the top and bottom by the square root of x plus 4 plus 2. Then at the bottom, it's going to look weird, but you are not going to distribute anything. You're going to leave it as exactly what you see. Root x plus 4 plus 2. Up top, because you have conjugates, you just do the first parts and the last part of FOIL. Take a look at that. Plus 4 minus 4 cancels, leaving you with the limit as x goes to 0 of x over x times this conjugate. Now this is great because the x's cancel. Now be careful here. I'm seeing too many errors and it's not a good error. This is going to be 1 over root x plus 4 plus 2. And then finally I can let x be 0, and you can't see that. Now you can. Finally I can let x be 0, so it's going to be 1 over the square root of 4 plus 2, which is a quarter. 1 over 4. All right. 9 and 10 to finish this one off. Again, pause this whenever you need to. This would be a good length in the video here. Let's talk about 9 and 10 to finish this. And then remote kids, you'll be good here for about a week. All right. And then I will fill you in with some new notes as we go. We spent a lot of time doing some algebra, though. So the limit as x goes to -4. What we're going to do is we're going to factor the top. X times x plus 4. All over x plus 4. This one's easy peasy. Look at that. The x plus 4's cancel. So now you have the limit as x goes to -4 of x. So your answer is -4. All right. Then lastly, 10 here. Anytime you have a root, should be, a lot of times you have a root, you should be thinking in conjugate, especially a root in another term. So if I plug 3 in, nope, I made a boo-boo here because when I plug 3 in, I don't get anything actually bad. All right, yeah, that was a typo. So x minus 9 over root x minus 3. Now when I plug 9 in, I am going to get 0 over 0. Okay, so the limit as x goes to 9, whoa. We're all over the place here. I gotta multiply time bound by that conjugate of the denominator. So root x plus 3, root x plus 3. All right. Now I have the limit as x goes to 9 of, again, don't distribute this. In the bottom, you have x minus 9. Up top, you have x minus 9 times root x plus 3. Now the x minus 9s will cancel. All right, now the x minus 9s will cancel. Notice how I continue to write the limits as x goes to 9 of root x plus 3. I can plug 9 in for x. 3 plus 3 is 6. 3 plus 3 is 6. All right, folks, that's your notes video for evaluating limits. This is Yak Math Video signing out.